The bright active regions are turning towards the far side, and that big filament erupted as well, but we'll need a better wavelength view to see it. Solar wind up first here, though, as we are very slowly entering a faster solar wind stream. Faint edge of a coronal hole, and geomagnetism is quiet thus far, handling it well. In 304 angstroms, you can see all the eruptions. Numerous filaments ejected, including the incoming and centrally located plasma ropes. The central one, erupting last here, went off completely to the right side, meaning luckily the bulk of that CME should miss Earth. Quick seismic note as a 6-pointer rang northern Argentina this morning. Luckily that's a blot echo, and at 190 kilometers down, surface damage should be minimized. 2 notes on the upper reach and then 2 on internal dynamics, starting here with the first identification of unreported small-scale structures in Earth's magnetic field. Pretty sure it was just yesterday I said I'd expect to continue reporting these anomalies and new features as the field continues to change during its modern shift. Up next, a drop in the solar wind the last few sunspot cycles shouldn't be surprising anyone here, but it is nice to see it laid out. It speaks to the downward trend of the solar output that is also seen in sunspots and magnetic field strength. Sadly, dropping to lower levels means less frequent but more build-up potential for those rarer events. Now let's come back down to Earth, where the ocean conductivity has been mapped at the surface, in the deep, and in the sediments on the ocean floor. Banded peak readings at low latitude, which is expected since it has the highest salinity. But now let's go even deeper and drive a stake into the heart of one of the 2 leading theories of the LLSVPs, the large low shear velocity provinces, Earth's internal skeleton. The competing theory taking the stake today is the idea that these are nothing more than recycled crust that's subducted downward. And it's wrong. While the analysis did find evidence of subducted material near the eastern boundary of the Pacific plume, the plume itself is not recycled material falling down and piling up. They are core mantle boundary protrusions sticking out of the core, which is why they carry the denser and more conductive character, just like core material, even as they finger up through the mantle into various hotspots around the globe. It's the #1 seismic challenge during the greatest solar blast, as it can take the normal mantle induction and feed it to the core. Mantle heaving, volcanic disaster.